Hey there, this is Seth Waters from Channel 9 coming to you from our beautiful brand new studios here in Studio A. I have a special guest, Michael Reese. How you doing, buddy?
Thanks. Very good. Thank you for having me.
So there's a really fun event happening soon. Why don't you tell us about that?
Yes, so we have the Microsoft Data Summit over in Atlanta, adjacent to the Ignite conference as well. And I have the pleasure attending the conferences and teach about USQL a bit.
So you have two talks, right?
Yes.
So obviously we can't, so we're not going to do the talk here because we got to.
Of course
have
not.
Have you written it yet? Let's be honest, people are watching.
I've done some of the demo.
Oh, he's ready. So I figured that instead of that, you give a little taste for what your talk might be like, and then also get us a flavor for what USQL is. How about that?
Sure,
Let's
okay. So the first talk is going to be about introduction of USQL, what is USQL, why did we do USQL, etc., and kind of show a little bit some of the strengths of USQL about using user code extensibility. And then the second talk is a little bit more scenario-based, like showing some examples about how can we use USQL to do at-scale image processing, or how can we do it to do JSON processing, or even how can I invoke R from within USQL. And so I can maybe tease some of that today in the recording.
Let's do it. So before we do that, if you could give me like maybe a 1 or 2 sentence overview of what USQL is. I know what SQL is, and T-SQL, right?
Yes.
What's USQL? Is it like the next one?
Not quite. So USQL is the language that we designed for doing big data processing in the Azure Data Lake. So its main focus is taking the strength of USQL, the ability to be declarative and not having to worry about how to scale it out because the system will do it for you, with the power of extensibility that modern programming language like C# gives you.
Sure.
And as such, it is looking very similar to SQL, T-SQL, etc. Obviously, it's a subset in the sense that it's primarily focusing on the select query statements. But it's augmented with the ability to very easily put in your own user code and then have the system scale it out, as well as being able to operate on unstructured data. So kind of having a little bit more than just the rectangular nature that you're normally familiar with a relational database.
And that's interesting because you mentioned that it's a strict subset in the sense that it only is doing selects. You're only pulling data, which is normally the only thing you would do when you're doing data science-y type things.
Yes.
All right, let's dive in.
Okay, so the first example that I have here is an Excel spreadsheet that contains some Twitter data that I got. It shows me the date and the time when it got tweeted, who tweeted it, and what the tweet was. And if I go into my code now, what I want to do is I want to do some analysis. I want to see how do the people that are tweeting ranking against each other in terms of numbers of tweets, for example.
Got it.
Also, how do they rank in numbers of how often they are mentioned. Now, you might have noticed there's no mentioning column, so I have to go and process the tweet itself to extract who gets mentioned,
Sure.
and so on. So I'm going to use C# to do that. So there's a script here that I'll show you just quickly at a high level, where I extract the data, and I extract that not just over a single file, I actually extract that, let me scroll up here quickly, over a path that can contain a wildcard. So I can go and actually extract it over many files at the same time. That then will basically just get scaled out by the system. And then I do some SQL statements here. Don't look at it very in detail. But one thing that it does here, it basically extracts the mentions from the tweet. And then it does some additional union and aggregation, so that in the end I basically get an array of basically where the data comes from in terms of files, but I also get for each name and for each category, whether the person was an author or he was mentioned,
I see.
The number of tweets. So
and that's interesting, right? I mean, it feels like, I'm sorry to interrupt, but this feels like the data cleansing and aggregation part of any data science process.
Exactly. So I have some data, and now I want to move it into the format that I want for my analysis. Now, one of the important aspects of the data lake concept is that I'm keeping the original data around in the lake. And I'm cooking the data into the format that I want for that particular analysis, so that I can always go back if I have a new question that I want to ask. Now, if I, for example, want to know what are they tweeting about, if I would have prepared the data like this, I wouldn't know because I only have the mentions. But because I can come back now and look at the original data, I now can see and can now ask new questions again. And I think that's one of the important aspects of the data lake paradigm is that you can always go back to the original data and do new investigations that you might not have thought about when you originally acquired the data.
And I heard from a data scientist, very prominent, she's really smart, she said you never get rid of data in its original form.
Yes, and so the data lakes should give you that capability and the capability of then cooking the data into what you want.
That's awesome.
So what I did was here is I then basically for better storage, because I have then some indices and some clustering here, I put the data into a table, and then I do my analytics on it. Now, the analytics that I do here is using standard SQL statements. Here you see some windowing functions where I calculate, for example, the median tweet count in each category to compare the tweeters to see how they actually compare against the median. I rank them based on a relative rank and an absolute rank. And then in the end, another thing is I wanted to then also calculate basically how do people kind of influence the community. Now, if somebody tweets a lot but he never gets mentioned or replied to, then he's kind of inconsequential, so he doesn't have a big influence. On the other hand, if somebody doesn't tweet a lot but get mentions more often, then I consider him to be a more influential person.
Sure.
So I have already run the job, so let me quickly go there and show you the job graph. So this is the execution as it looks like when it runs against our cluster.
Wow.
And down here now I have the output file. So I double click on this, and this now opens me a preview of the file, of the result. And let me, once it opens.
Well, as it's loading up, this is interesting to me because traditionally, when I did any data science stuff, I would write this code in Python that would do all this stuff. And when I look at it, I didn't know what it was doing afterwards, like a couple weeks later. When you're looking at this sort of use SQL, it's saying, let's do this. It's very declarative and it helps you see what's happening.
Exactly. It's very declarative. It kind of allows you to do stepwise refinement. If you want to add something new, you can just add another statement into it. Unlike normal SQL systems where each statement gets executed individually and then only locally optimized, in our case, the whole script gets optimized. That means you can kind of make scripts that are looking a little bit more substantial, so to speak. So now here you see, for example, Raghu, our TF in our team. He doesn't tweet a lot, but he's very influential because he gets more tweeted at, while other people, they tweet a lot, but they might not be as influential using that metric that I was using.
That's pretty amazing. And so in a couple of statements, you're able to sort of figure this out. Now, the question I have is when we're looking at that graph, because my concern is this is nice if we have like, I don't know, couple 100,000 rows, you could do it in RAM.
Yes.
But what if you have like 100,000 CSV files?
Yes.
Are these things happening on the same machine?
So this will be scaled out depending on how big your data is.
Oh, I see.
So for example, if that table would contain, I don't know, a terabyte of data, then depending on how much resources you're willing to pay for, you could scale that out over 1,000 nodes.
And so you could effectively get the hose of data from all of Twitter for the last week, which is a huge amount of data, and then it would just scale out and you would use the same query and it would still
Exactly, it would have exactly the same script. You wouldn't have to necessarily go and like think about it. The only thing you do is you submit it and you say, please use that many resources to parallelize it. And then everything else will be taken care of by the system.
And then eventually at the end out comes this influencer.csv, which is that's pretty cool because you could imagine a situation where you're analyzing a hashtag that's important to you, and you can analyze it for months.
Yes.
And you could use this to do a lot of analysis.
Yes.
That's pretty cool.
So this is one example.
Okay.
Now this is very structured data in a sense. Let me now go to something that is completely unstructured.
Let's do it.
This is kind of harking back to an example that we had back in Bing, where Bing is actually doing image analysis on our data And they do things like, for example, thumbnail extraction.
Sure.
So let me quickly show you some sample data here. I run this local for once. So I have here a lot of pictures. I'm currently looking at one picture here. So this is a picture of a green car that I took at some event.
Nice. Is that your car?
No, unfortunately not.
Yeah,
Mine is also as green, but it's not a Lamborghini.
I was just checking.
And what I want to do is now I want to go and extract the some of the properties that a JPEG file has, like which camera was it taken with, what is the copyright notice if there is one on it.
The EXIF data.
Yeah, the EXIF data. And also I want to create a thumbnail on this.
Okay.
Now the first one is kind of like I do feature extraction. Now, of course, this is a very simple feature extraction, but you could imagine that you're running some custom code that extracts image-specific features like gamut or color distribution or things like that, so you can do additional like analytics on. And the thumbnail creation actually takes an unstructured file and creates another unstructured file.
I see.
And we are still using SQL. So we are still using the language that originally was called the structured query language.
Which is interesting, right? Because the first ones, I mean, when you look at it, it's a very different sort of thing. Images are not the same thing as text in a CSV file. Very different.
Yes. So in this case, here's the script. And again, I'm not going to go into too much detail how this is actually being enabled.
Sure.
For that, you will have to come to the Data Science Summit. But what I show you here is I basically extract the image data from this image file. And then I run some custom code here that basically extracts copyright, equipment, make, model, and description from the image file itself. And then I output the properties into a CSV file. And then I do an image operation on my binary blob here that rescales the image down to a thumbnail of 150 by 150 pixels. And then I just write the thumbnail back out. Now, this one I actually can, I'm running this local, but because it's a little bit quicker in terms of response time. And then I get 2 files down here. I'm opening from within the tool, I can open the CSV file. And let me just zoom in here quickly as well. You basically see now the copyright, image equipment, and image description information here. And if I go back into my output directory to open the image, you will notice that Lamborghini now has shrunk so that I can take it with me and put it into my pocket.
That's awesome. So in the query, and I know you didn't want to dive into this, but I'm just dying to understand this. You were calling image dot, and then it looked like, is that C# code? Is that a static class you're referencing in an assembly?
Yeah, so this is static code that I have provided in an assembly. I referenced the assembly at the beginning here with reference assembly images. This is previously registered inside what we call our metadata store. And it actually uses some C# code that in turn calls out to system.draw.
I see. Okay. And so if you're pushing this up to do it on a large scale, will the assembly live on all these machines as well?
So what will happen is the assembly lives inside the metadata store.
Okay.
And then when I create the job graph for that specific job, then each node will get a copy of the assembly so that it locally runs.
That makes
so
sense.
what we basically do is we give you the framework to scale out your user code that way. And you don't have to worry about it. So it's all, you register it, you write the code, and then which is doing the business logic, meaning the thumbnail creation, the EXIF extraction.
Sure.
And we will take care of scaling it out for you.
And that's interesting because I imagine that you could do the same thing, but with R, for example.
Good question. So let me show you some R.
Oh my goodness! It's like we practiced this.
Yeah, we probably
didn't
talked about
practice.
this.
It's the first time we've ever. Yeah.
The first time we ever saw each other.
Yeah.
Okay, so here I have an Excel file that contains over 10,000 triples, and consider these to be, I don't know, coordinates in some coordinate system.
Sure.
And now I want to do some data sciencey stuff over it. Basically, I want to calculate the centroids of 2 clusters.
Okay.
Over the
so
data.
Like k-means, for example.
K-means, yes. Yeah. So let me go and show you how, again, just at the high level how this can look like in SQL. Let me actually increase the font size here a bit. So here now I'm using basically R.NET and some other R sample runtime here. And I'm basically, again, referencing these assemblies. To do so, I have to go now and deploy the rbin.zip file. That means also, again, it gets allocated to each one of the nodes.
So it's in the metadata store.
No, this one actually is not metadata per se. This is just putting it into the file system, into the local file system on each of the nodes so that it's available there.
Got it.
And that's because it's a zip file, so it's not a DLL.
Yeah.
And then what I do here is I basically have the input is my file that you just saw. I extract that with a custom extractor where I basically take the triples and move them into a SQL array of double. Then I just counter the number of rows here, which is probably less interesting. And then down here, I basically calculate the k-means for two clusters. And then down, and this is basically calling into R. I can show you the R code quickly. And let me increase the font size here too. And scroll down a little bit. There is obviously some stuff here, but here's the R expression.
I see.
And obviously, this is now wrapping an R expression into something that you expose as a named object, meaning the k-means R engine operator. You could theoretically also do something that is a little bit more generic that basically says, okay, here's the input type and the output type, and any R expression that takes the input type to the output type, I can pass in as parameter. That would be another way. So obviously, again, I can run this locally. I think I've done that before. So here is the result. I have two clusters now, and these are the two centroids for the data that I inputted.
That's awesome. Now let's go back to because I saw something that looked map reduce-y. I think it said reduce and produce. Is that right?
Yes. So the reducer here is basically a way of creating something that is similar to a map reduce step, or what I would call a custom user-defined aggregator at a row set level.
Got it.
So it can take a row set and it can reduce the cardinality of the row set, or it can even potentially expand it if, although that will have interesting implications on the optimizer normally.
Yeah.
In this case, what I do is I actually run this over all the data. Obviously, if I have, let's say, a partition identifier, let's say the region, and I want to do it in a per region environment or so, then I can do that scaled out over each partition.
I see. Yeah, because k-means is you kind of have to go through all of them, but then if you're going to parallelize it across different machines, you got to do it by region.
Yes.
That's pretty cool. Well, I'm thoroughly convinced that we should come to your talk.
Okay, cool. I'm seeing you all there then.
So just to give folks a little bit of an understanding, what's the Microsoft Data Science Summit?
So the Microsoft Data Science Summit is, I think, the first time that we have a public conference where we are basically going to show off and engage with the community around our data science offerings, both in terms of software, but also other expertises. And it's basically for us to show what we have, to listen to you, to the customers, to see what they want, and kind of start engaging in a hopefully fruitful exchange of ideas, and hopefully we'll learn more about the use cases, and you will learn more about the products that we have in this space.
Fantastic. Well, thanks so much for spending some time with us. So we've looked at SQL today in all of its glory. Well, not all of it, in a small sliver of its glory. Thanks so much for spending some time with us.
Thanks for having me, and see you in Atlanta.
Thank you. My name is Seth Juarez, Channel 9, and hopefully we'll see you there. Take care.